Large language models, deep learning, ChatGPT. These terms dominate headlines today, and they are frequently used as if they all mean the exact same thing. Treating all artificial intelligence as a single, uniform technology creates immense confusion. In a business environment, that confusion is expensive. Running a massive generative model to perform a basic spreadsheet calculation burns unnecessary compute power and drives up operational costs. To build effective systems, we need clear definitions. Artificial intelligence is a broad field of computer science dedicated to solving problems we typically associate with human intelligence. The field attempts to replicate very specific high-level capabilities. These include perception, reasoning, learning, and complex decision-making. To actually harness this technology, we have to look past the broad label. We need to drill down into its nested layers. Early systems did not learn. They relied on expert logic engines and rigid, hard-coded rules written by human programmers to reach a conclusion. Machine learning shifted that approach. Instead of static rules, algorithms discover patterns in historical data. Training with labeled data, like connecting a house to its price, is supervised learning. Feeding raw data to discover hidden groupings is unsupervised learning. Finding solutions through a trial-and-error reward loop is reinforcement learning. Machine learning excels at structured data analysis, but it struggles to process highly complex, unstructured information. To handle unstructured inputs like raw audio waves and high-resolution pixels, researchers developed deep learning. This image shows a visualization of an artificial neural network. Deep learning relies on these multi-layered architectures, which are mathematically designed to mimic biological synapses. This visual demonstrates real-time computer vision from a moving car's perspective. Deep networks power these advanced perceptive tasks, instantly identifying pedestrians and traffic signs. Inside deep learning sits generative AI, capable of synthesizing brand-new content. Foundation models process inputs by breaking text into numerical fragments called tokens. Those tokens convert into vector embeddings. By mapping these numbers onto a coordinate grid, the model grasps semantic context to generate human-like responses. Generative AI is the deepest subset of machine intelligence. It crosses the threshold from statistical categorization into true digital creation. The artificial intelligence ecosystem is a nested hierarchy. AI contains machine learning, which contains deep learning, which houses generative AI. This flowchart illustrates a transaction being scored for potential fraud. Using historical data to predict a risk score is a classic application of traditional machine learning. This image shows a targeted digital overlay locking onto a red stop sign. Processing a physical environment in real time requires the complex neural networks of deep learning. This illustration demonstrates a simple text prompt commanding a system to render a novel piece of artwork. Synthesizing new media is exclusively the domain of generative AI. Because these powerful models train on massive datasets of human information, they can easily inherit biases or hallucinate false facts. This requires strict, responsible AI practices. Enterprise deployment relies on built-in safeguards. Engineers implement fairness checks, robustness testing, and transparency protocols to ensure the system remains safe and reliable. Technical mastery requires knowing your tools. By mapping the right layer of intelligence to a specific problem, teams build solutions that actually work.